In this video, we are going to find all positive integers x and y, prime numbers p, such that xy cubed all divided by x plus y equals p. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. To solve this equation, I'm going to consider the greatest common divisor of x and y. So I'll call this number d, which is supposed to be another positive integer. Then I can write small x, say as d times big X, small y equals d times big Y, with x and y both positive integers. I should write big X and big Y here. And with these two positive integers being coprime, which means they do not share any common prime factors. Now, from this, we can rewrite the equation as d times big X times d times big Y all cubed over d big X plus d big Y equals p. And for this fraction, we can simplify, and we have d big X big Y cubed divided by big X plus big Y. Now the difference is, for the x and y, they are now coprime. They do not share any common prime factors. And not just that x and y, big X and big Y are coprime, we also have big X and big X plus big Y. By the Euclidean algorithm, the greatest common divisor of these two numbers is equal to that of big X and big Y. So again, it's equal to 1. So these two numbers are coprime. And of course, we can do similar things on y cubed. For this, we only have to consider any prime factor of y cubed, which should also be a prime factor of y, and it should not be a prime factor of x plus y, or else this prime will also divide x. So that will contradict the fact that x and big Y do not share any common prime factor. So that means the three parts labeled with a box do not share any common prime factor, but the fraction on the left is supposed to be a positive integer, a prime number in particular. So that means the only possibility is that d cubed, sorry, there was a mistake above, there should be d cubed, and this fraction equals p. Sorry, it's not should be equals to p, but it's a positive integer. What I want to say is it's a positive integer, and it's a factor of p. So that means we have two cases. Either this fraction equals to 1 or is equal to p. And for each case, we'll have either d cubed equals big X plus big Y, and the other parts at the numerator, which are big X times big Y cubed equals p, while on the other hand, for the other case, d cubed equals p times big X plus big Y, and the other parts of the original fraction, big X times big Y cubed equals 1. For the first case, big X is a factor of p, so it's either 1 or p. But if big X equals to 1, then big Y cubed equals to p. That's impossible. So big X equals p, and y cubed equals 1, so y equals 1. So therefore, d cubed equals p plus 1, or I can rewrite that as p equals d cubed minus 1. However, a prime is now factorizable. So the only option that allows us to proceed is that one of these parts of the product equals to 1, and we must have d minus 1 equals to 1 because it's the smaller number. So therefore d minus 1 equals 1, d equals to p equals 7, and so then we can solve for x and y. Big X equals 7, big Y equals 1. So therefore small x equals 2 times 7, that's 14. Small y equals 2 times 1, and that's 2. And indeed, if we do some checking, 14 times 2 cubed over 14 plus 2 is indeed equal to 7. So this is a valid solution. Now we can move on to the other case, which is when big X times big Y cubed equals 1. Then obviously those two numbers must be 1. And so therefore d cubed equals 2p. But that's impossible because 2p cannot form a cubic number. So no solution. And we'll quickly arrive to the only solution, which is 14, 2, and 7. So this is the final answer. Please feel free to share ideas in the comments. Thank you for watching. See you next time.